Welcome to Technology Plugin T8 for the Mac. And in this lecture we're going to get into some more advanced SQL. We'll be talking about joins, and then we'll also be talking about set operations. So we have data, as we saw in our schema, in multiple tables. And sometimes we're going to need to get information from more than one table. One table just doesn't have the complete set of information we need. We need it from several tables. And we also might need to match them. So in other words, we want to get, say, a student's information along with their associated department information. Well, that's in two tables, and so we have to do two things. We have to join the tables. Well, we join them together, and that does two things. It lets us access the information in both tables, and it performs a match for us so that a student is matched to their proper department, and then we get the proper department information for that student. So a join is performed when data is to be retrieved from more than one table. We use the from clause to list the table that we were interested in our last lecture. Well, here we do the same thing, except we're going to have more than one table. So the tables are joined by listing them in the from clause with commas between them. Or we can also use the certain syntax, such as natural join, and then we just say table 1 natural join table 2. Join operations take two tables and return another table, one table, as a result. A join condition is how we're going to match the two tables together. And then a join type is, do we want only the records that have a match, or do we want all records of one table and then any matching records that are in the other table? So we'll look at all of these conditions in the lecture today. To help us join tables with some of the different ways there are of doing it, an alias can really benefit us. An alias identifies the source table from which the data are taken. And it's really a single letter typically that's used. It can be any legal table name, however. And again, it's typically a single letter to reduce typing, because we're going to use that alias in place of the name of the table. So for example, we could say from student space S, or from student as S. And then if we needed to qualify any fields by the table name, instead of having to say student.id, for example, we could say s.id. So it shortens our typing. We add an alias after the table name in the from clause. It can be something like from table name alias. It can also be in the form of from table name as alias. So let's go ahead and do a few joins. And there's a couple of different ways of doing the joins. So we'll go ahead and look at each of those different ways of doing a join. So our first effort is to join the student and department. So find all students and their department information. So one approach to doing this is to select star. We're going to get all the columns or all the fields from student natural join department. So The SQL syntax there is from and natural join. We put in the tables we're interested in, the student table, natural join to the department table. So let's go ahead and take a look at this in SQLite. So I'll say select star, enter, from student, natural join department, and you can see we get the student's information, and if you'll recall, the student table has the student ID, student name, the department that the student is in, and the total credits the student has. The department has the department building and the department budget. So now we have associated with a proper match each student with their department. So this is the natural join approach to doing a join. We use the keywords natural join in our from statement. Another way we can do it, and this was the original way that SQL did these type of joins, is to just put the join condition in the where clause. So again, we want to find all students and their department information. Select star from student as S, so we're using an alias of S for student, comma, department as D. We're using D as an alias for department. So in our from statement, we are identifying the two tables we're going to get information from, student and department. We also give ourselves a handy shortcut so that we don't have to type out the full table name as a qualifier. The where clause is where we put in the condition that matches the two tables together. S.department name equals D.department name. So department name is a field name in both student and department. Both those tables have a field with the same name. So we qualify that with the name of the table so that the compiler can know which particular department name we're talking about. S.department name equals D.department name. That will give us the match that we need. And again, that was the original way of doing it. And it's the way that Microsoft SQL Server preferred people do for quite a while. Okay, so let's try that one. Select star from student, as S, department as D, wait a minute, where S dot department name equals D dot department name, semicolon. And now you see we get a join on those two tables as well. Notice the difference between this one and the natural join. We repeat the column department name in the old approach. The natural join gets rid of duplicate columns that are used in matching. Okay, let's look at some other ways of doing joins. So again, we have the same join between a student and their department. The question posed to us is find all students and their department information. So we can do select star from student join department using department name. So let's take a look at this one. So here we have it, select star from student, join department, using a particular column common to both of them, in this case department name. And again, we get a join between a student and their department, and we can get the associated information matched together properly for us. And there's another way we can do a join. So again, same join between student and department tables. I'm sorry, in this case we're going to use advisor. We're going to use the join between the student and the advisor. And we want to get the advisor ID. So we're going to look at this. We're going to say select star from student as S, join advisor as A on S.ID equals A.ID. Okay, let's take a look at this in SQLite. So here we have our SQL query, select star from student as S, join advisor as A on S.ID equals A.S underscore ID. And so in the advisor table, we have both students and instructors. Both of them have a field called ID. So in the advisor table, we list the student ID as S underscore ID and the instructor ID as I underscore ID. So now we can match on fields that, again, just like we did with the where clause, do not have the same name. So notice we're matching ID to S underscore ID. And we can see the ID for student Zhang is the one under SID for this particular advisor record. And so student Zhang has an advisor with an ID 45565. And of course, we could use that ID to find the name, for example, of the advisor. So let's take an example where we've got the table course and the table prerequisites. Obviously, courses have prerequisites. And in our particular case, we've got, in this example, prerequisite information for course 315 doesn't exist. Maybe it doesn't have any. And then course information for a prerequisite is missing for course ID 347. So we're only going to match on the ones that have the same values. So let's take a look at this in SQLite. Okay, let's clear this out. Usually I clear that out, but I forgot. Okay, so select star from course natural join prereq. So in this case, we've got a number of courses, and they have, each one of our courses is listed if it has a matching prerequisite. So if it doesn't have a prerequisite, we're not going to be seeing the course in this particular query. So what happens if we want to see courses even if they don't have a prerequisite? Oftentimes courses at universities do not have prerequisites. It would be a mistake for us to just list only the courses that have prerequisites. We would be missing a significant number of legitimate courses. An inner join that we have been looking at up to now only returns records from the two tables if they have matching values on the join field, like ID, for example, that we've used several times. But again, sometimes we may want all the records from one table, and if they have a match from the other table, include those fields for that record. However, if they don't have a match, we include them anyway, and we put empty space or nulls in the spots that the other table's data would go if there had been a match. So this is an extension of the join operation that avoids the loss of that information. In other words, information from that one table that we want regardless of whether or not it has a match in the other. So it computes the join, and then it adds the tuples from one relation that do not match the tuples or rows or records in the other table. And it fills in with null values. So for example, in the case of the slide join 2 slides ago, we could show a natural left outer join and include the course CS 315 Robotics, course department name, computer science, credits 3, and then in the prerequisite field we leave it empty or null. In other words, we don't have a prerequisite for this course, but you may be interested in it anyway. And so here's some examples of some joins that we might do: an inner join, and then we see we have a left outer join. The inner join gives us the 2 records where we have exactly matching values. The outer join includes a record from the first table, course, that doesn't have a matching value, and in its place null values are put for the prerequisite information. So let's take a look at a left outer join in SQLite. So here I do the left outer join. Select star from course natural left outer join prereq. And you'll notice it includes all of my course information, and then if it has a matching prerequisite, that matching prerequisite is listed, but if it doesn't, then it puts in null or empty space as a value. That way we know that we have a course Finance 201 investment banking, even though it doesn't have a prerequisite. We can display it and show that it's there in our class schedule. Okay. So at this point, let's go on to set operations. So we said that the results of our queries are in effect tables, temporary tables, and we can do set operations on those. And there's typically 3 set operations that we might want to use: union, intersect, and except. Now, these will work if the tables or that you get as your temporary tables as results have the same number of fields and the data types are the same between for those fields. And that's known as being union compatible. Now, a union combines rows from two or more queries, and it doesn't include duplicate rows. So let's say we want to find courses that ran in fall 2009 or in spring of 2010. Well, we can do that with our union. So a union is used for situations when you want to do an A or a B. So you would do A union B in our set operation. Oops, let's clear this out. And so here we did that. We have a complete query, select course ID from section where semester equals fall and year equals 2009. That's a complete query. It's going to return a temp table. We're going to union that with another query's results. This other query is select course ID from section where semester equals spring and year equals 2010. Notice we're going to be joining the two sets of data that we need for our answer. And of course it does that. And they're union compatible because the field that we're going to have in our temp table is course ID in both of the temporary results. So that's a union set operator. Next, let's take a look at an intersect. That's going to combine rows from two queries, returning only the rows that appear in both. So with the union, it's an either or. In this one, it has to be a row to be included in the output, has to be in both of them. And the syntax is going to be query intersect query, just like the syntax for the union was query union query. So we would use an intersect when we have an AND type of condition. Find all the courses that ran in fall of 2009 and in spring 2010. That means the course has to be in both fall 2009 and in fall 2010. So let's take a look at this. And wait just 1 second. Okay. So now we do the same two queries, but we are going to have the set operator intersect instead of the set operator union. And notice there's a big difference in the size. We only have one course that was taught in both fall 2009 and in spring 2010. And finally, we have courses, or we have situations where we want to get information that's in one table and not in another table. So here we have the except keyword, or the except set operator. Oracle uses the word minus. As I mentioned, a lot of times the more established database vendors like Oracle and Microsoft and IBM used their own prior solutions to these problems before there was a standard that addressed them. And so Oracle, rather than cause a lot of harm to its customers, is going forward with the word minus. SQLite uses the word except, and that's the SQL 92 standard for it. So anyway, what we do with an except is we combine rows from two queries, and we return only the rows that appear in the first query and not in the second. So let's find all the courses that ran in fall 2009, but not in spring 2009. Oops. Okay, so let's take a look at that one. So here we have the two courses that ran in fall of 2009, but were not taught in spring 2010. Okay, so that concludes our set operations. You do have homework for T8 for the Mac, and there's 7 problems that are in the PDF here. Write the SQL queries for 4 of them. Each answer is worth 25 points. Partial credit is going to be given, so don't send me blanks. And send me your results using Sakai messages. And the due date is in the schedule section of the syllabus. And again, here's a schema, so you can see it's a roadmap for you to use on where to get the data. And then here are the queries. All right. Thank you.